conference. Thank you very much for all the volunteers who are responsible for this event. It's a huge one and a lot of work. So this is my first time actually presenting, and to be honest, I'm quite terrified. Yeah, and that said, I'm really excited to present this topic. It was bothering me for maybe 4 years at this point, and I finally got some time to dive deep into it and found a way to make a connection and solve it and ease my life to make it much easier. So yeah, so before we start, a disclaimer. Here, everything I'm talking about is for educational purposes only. Do not attempt to interact with systems you don't have explicit permission to access. Always ensure you have proper authorization. Remember the name of the school we are in, and don't do illegal stuff. Yeah, so my name is Ilya. I am currently a graduate student at UMD. Go Terps! I've been doing offensive security for almost 5 years, specializing in penetration testing, red team exercises, and vulnerability research. Grab a bunch of certs. Those two, if you can, I hope you can see some text there, are most important ones in my opinion. I had a privilege to be an intern at Praetorian this past summer, and when I had a moment of a free time, I decided I want to give back to the community something. So I contributed to Impacket and NetExec. By the way, the code for for this specific talk is also available as a pull request for GitHub. I made the pull request while I was on the train going here. Yeah, so I'm going to talk about remote desktop services shadowing feature. What is it? How to enable, disable it? How to use it, where did it come from, and how to use it from Linux actually. And that was a problem that bothered me a lot. Why did I select this specific topic? Because I really think it's cool. Because it's some kind of something from Mr. Robot kind of thing. You're actually able to spy on users while they're doing work and not bothering them. If we get a little bit more serious, I guess, picture the situation. You're a penetration tester, you are doing an engagement, and you have a specific task, like you need to obtain a screenshot of a specific system which only a single employee allowed to access in a certain period of time. The only way I knew previously how to do it was to obtain some sort of network visibility to the system and try to connect there using RDP, do the screenshot, and reach the goal. There are multiple problems with that approach, and the most important one, in my opinion, would be the fact that if this employee has an active session and you obtain the credentials for this employee and attempt to connect using RDP, you would kick this person out of the session and interrupt his workday. That's a problem. We don't want to do that. Around that time, 2 blog posts appeared in a span of 6 months, and those blog posts described remote desktop services shadowing feature, which solved the exact problem that I just described. The only problem was it is not supported by open source tools like FreeRDP, for example, or RDesktop. So the only way I could use this feature is by bringing my own additional virtual machine. I needed to switch the context. I needed to use the default RDP client of Windows, and I also, if there was not a direct network connection, I needed to proxy the entire virtual machine and make sure it actually works properly. So that's quite a hassle, and I wanted an easier way. So I will explain how to enable this feature, because by default it's not enabled. In order to enable it, and I hope you can see at least something, there are 2 ways to enable it. One way, you would go for group policy preferences and enable it there, or in my opinion, easier one, you would create a special key using a registry. It's for like local machine, terminal services, and to no one's surprise, the key is called shadow. There are different values to it, but we would use a value 2 just because it works. Yeah, surprisingly enough, as a prerequisite, we need obviously direct network access, but we do not need an access to RDP port because this feature does not use it. This feature works over RPC. It's a single RPC call, and then it uses ephemeral ports from the higher range, and those are basically 2 ports that we need. Also, we need to make sure that on a target host, the RDP services are running, and also that it's not corrupted in any way, and we have all the necessary binaries that come by default there. Yeah. So how would the typical workflow look like? First, to enable it, again, we ensure that we have the correct credentials and like elevated ones because we need to modify the registry key. Secondly, we need network access. Then we would switch the context to be an administrator because when we are using the default RDP client from Microsoft, we are using it from like PowerShell, for example. It does not prompt you for the credentials, so you can't select it. So first we need to run something like run as or do pass the hash or pass the ticket or whatever you need to do to switch the context. Then we would enumerate sessions on the target machine and see the session ID that we are interested in. After that, we just supply a bunch of parameters to default Microsoft client and connect. So I prepared a demo to not anger the gods of demonstrations. So here, I hope you can see something. On the left, it's my virtual machine. I'm trying to demonstrate how I used to do it. So on the left, it's a virtual machine. On the right, it's an actual RDP client. And on the left, I will first switch the context because by default we assume that everything is going on my host, so everything has a direct network access. I switch the context using run as to the target machine administrator. You always can shadow a session of any user on the machine if you're a local admin. But additionally, if you even don't have like specific admin credentials, but you're somehow able to modify the registry keys and all that other stuff, you always able to shadow your own session unless it's started from the same machine you are currently working from. So if the person has connected, let's say, from Seattle to New York, and I am sitting, I don't know, in San Francisco, it would be perfectly possible for me to shadow the session. So, I'm a little bit behind, sorry. So on the left, I just switched the context, found the session ID using Quinsta, and using the supplied parameters, I just demonstrated that we are on the left, we are attaching to the same session, and now it will be the example with control. We can not just only watch, we can also interact. But also we've just seen that there was a prompt alarming the user that someone is requesting control. We can disable it because, Microsoft decided it would be a great idea to give you a flag that would hide this prompt. There is a small issue with that because you need to set it up properly in the registry. But now supplying the no consent prompt parameter, we will see that there is no prompt and we got the same view. And just to make the demo complete, I will do the same thing with the control and no prompt. So, it takes a little bit of time to load, and I do not know why because it's on the same host. Sorry about that. So there is no prompt. We can see that some window is appearing, and we can actually enter the text on the left. Cool, right? Again, it's a personal preference of mine. I prefer doing penetration testing in internal environments from either Mac host or from virtual machines on Linux-based distros. And I wanted to do that without bringing an additional VM. You can see, you can see all the commands. I provided them just because, well, I assumed you might not be able to see it. Also, if you see the links in the presentation, you don't need to jump around if you want to get, well, specific link. In the end, there will be a resources slide where all the links are placed. Yeah, so first command, we're switching the context. We enumerate the sessions. We check if the shadowing feature is enabled. We can see if it's enabled or not. We set it up, and then we just shadow in the brackets. You can see the flags. You can, yeah, you get the point. So what's happening underneath the hood? So when we switch the context, the client would make a call using an RPC interface. This one, I prefer not to pronounce it. This method, this interface exposes a single method called RPC shadow2 with operation number 0. It looks like this. All the info is on the Microsoft documentation website. So it takes as a parameters RPC binding, target session ID, which we found with Quinsta. Then again, we see some type of enumerations, and those are basically the control and no consent prompt flags, but they are defined as enumerations. As a result, we get back a permission. It's also defined as enumeration because there is more values than just allow or deny. And the most importantly, we get an invitation, like an old vampire. So this is how the enumeration looks. Yeah, so for the first one, despite the title of the presentation, I decided to stick with Windows and try to implement it there. And I have never implemented RPC interface before. So I followed this blog post from SensePost, which is really, really nice. And after setting everything up, I received that giant of an XML sausage. And I had absolutely no clue what to do with it. So I go back to the documentation and see that there is a reference to some protocol called MS-Ray. And it actually defines two types of those strings. So type 1 and type 2, it's called remote assistance connection string. And there are two types of those for older versions or newer versions. But is the remote assistance the same as shadowing, and how does it relate to one another? So remote assistance was introduced back in Windows XP, and shadowing was introduced at Windows 1.8 and later. In the server equivalent of Server 2012 R2 and later. To my current knowledge, remote assistance is either being deprecated or already has been and replaced by something called Quick Assist that you need to install from Windows Store. Remote assistance uses the expert novice model, which means the novice generates something called invite, encrypts it with password, sends the password using one way of communication, and the invite the other way. So, yeah, and when the expert uses both of those things to connect, it always will prompt the novice. So it's explicit, to grant explicit permission to access. Remote assistance gives following functions. So you can view and interact with the session. You can obtain control of a keyboard and mouse. There is a chat window, which is convenient. And well, session invitation file generation. You can generate the file and send it via email just using the remote assistance client. This is how it looks. So we basically open the msra.exe. We generate the invite. It looks like this below. As the LH ticket, it contains the encrypted type string 2, and as a second one, it's just invitation string type 1. And we can also see the password. So I am going back to the documentation. And there is a lot of text already, so I did not provide the page with password generation. So we can see how the flow goes. So now this generates the invite. The invitation string is generated, encrypted with a password. Everything is compressed to like MSRC incident file and sent over in an encrypted form to the expert. So obviously, I noticed that expert connects with a clear text string. So my thinking was that if I want to implement it in the open source using open source instruments, I want to do as little of modifications as possible. So my thinking was I already have the plain text string, so I can basically encrypt it and follow the format. I have the password generation thing. I have the entire process and the format of the file. So I can just encrypt it and then open it with default client to see if it works. And it did not. Yeah, I do not know what went wrong there. It may be my coding skills. It may be Windows handling the format somehow. I could not debug it. And also, I noticed that in my environment, and I am using Mac, so there are limited options to run Windows Server on it. So I had to use the Inside Preview for ARM. And I noticed that on my version of the Mac, on Windows, remote assistance it's not possible to enable remote assistance. But I have already seen that shadowing works. We saw the demo. So that at this point, I decided that I need to come back to the fact that I wanted to implement it using open source tooling in a universal way, so we can run it in Linux host as well. So I thought about FreeRDP, and I noticed in the help of FreeRDP that it uses it can use .rdp file configuration files to connect. And I just assumed that if it supports this type of file, that it possibly also implemented the assistance files as well. I tried to just search, and well, if there is a flag for assistance password, that means the files are supported. I attempted to use my encrypted my file, and well, it also did not work. Yeah, so at this point, what can you do? You can just take a break, and that's actually was a good idea. So what I thought of is let's just Google instead of let's Google for issues in FreeRDP, but not for shadowing because we know those are not implemented. But we will Google the issues for the remote assistance. And guess what? I found one. Somebody had the exact problem I had, but back in 2019, even before the blog posts were posted about the shadowing. So somebody had issues with parsing the invitation file in encrypted form. So somebody just decided to make a check. If the parsing of the invitation file fails, let's just check if the contents of the file look like the plain text remote assistance string type 2. Well, okay. I decided to just bring it to Impacket and make an RPC call there, save it as an incident file, and try to open it using FreeRDP. And guess what? It worked. Yeah, so sometimes structured research is not it's just an assumption which works. And imagine I could have done the entire thing 4 years ago, and there wouldn't be any problems. So for the sake of demonstration, I'll do the entire flow from using Impacket in NetExec. I'm using Mac. It doesn't matter. You can just you can use the default RDP client, the FreeRDP client. You don't need to change anything. Yeah. So first things first, I need to like enumerate the sessions, then using netexec, then enable the shadowing using netexec module. Very convenient in my opinion. Then we will use the modify TS tool, which is again available, so you can get it and try it yourself. Yeah, so I provided support for every parameter there, except I did it in reverse a little bit because I do not like the prompts, so I decided to make the prompt silent by default. Yeah, so we just generate the invite file and send it to FreeRDP client, and now it just works. Yeah, so the idea for this talk was first to fix one issue that was bothering me. Secondly, I'm terrified of public speaking, and I decided to make myself do one. And thirdly, I would like for this talk to be an example that you don't need, if you're interested in some topic and you want to present it, it doesn't need to be deeply technical, and you can just implement something, even if it's a small contribution, and then present it like at the event like this. Yeah, so you can see that we obtain without control, and now we demonstrate the same thing with control. So yeah, this is kind of what I would like to talk about. Again, all the commands are available. All the resources are also available later. As a responsible penetration testers, we need to clean up after ourselves. So from Windows, delete the key you created. From Linux, just use netexec, 2 commands, enable, disable, very, very convenient. If you are working on a defensive side, you need to be aware of this specific key and, well, shadow key. It's just one key to monitor, come on. You also can monitor for sys and public RPC pipe being accessed. To be honest, I don't know if there is any other use case for this specific one. It exposes a single element, single method. So yeah, and you need to be monitoring for RDP assay.exe file and assay proxy, because those executables are responsible for isolation and communication between the targeted session and your session. So they are ensuring permissions, isolation, and communication between those via the named events. Yeah, so monitor for them. So if they are running, that means the shadowing is in process. So yeah, that's how we can reuse the remote assistance to shadow someone's session from Linux. All the resources are available, and thank you for your attention. I hope you have a great day, and special thanks goes to people who are actually helped me and encouraged me to apply for the talk, to Michael Weber and John Stawinski, to my UMD professors Kevin Shivers and Michael Whitner, and Miss Perry and Mr. Smith-Sweeney, who are organizers and helped me with mentoring and preparing my talk. Thank you very much, and I hope you have a great day.